From the Analysis drop-down menu, select Interface Detection with Needle Probe. This tool allows for the computing and visualizing of the surface position and the interface position, both in units of millimeters, of a find contact function, which is a load versus position curve obtained from a needle probe measurement on a sample. This model is well adapted for the thickness measurement of samples composed of two layers, a soft layer on top of a stiff layer, for example, articular cartilage over subchondral bone. The needle probe measurement consists of moving the needle probe at a constant speed until it penetrates the surface of the sample and stops inside the interface. The difference between the position of the surface, that is the position where the load starts to increase, and the position of the interface where there's a sharp increase in the load, corresponds to the vertical thickness. This analysis can be used in two modes, either automatic or manual. In the automatic mode, the low-pass filter, cutoff frequency, and the loading limit need to be specified in order to optimize the interface detection for each different sample. The automatic mode allows finding the surface position 1 and the interface position 2 through an algorithm. In order to find the surface position 1, the algorithm will start from the maximum load and will slowly scan the curve until the load will be equal to the load at the starting point. In order to find the interface position 2, the algorithm will first smooth the curve with a low-pass filter shown by the red line, and will then compute the first derivative shown by the green line and the second derivative shown by the blue line. The position of the maxima of the second derivative will be considered as the interface position if its position is located before the user-defined loading limit. Therefore, the automatic mode consists of specifying two parameters, a low-pass filter cutoff frequency in Hertz. This defines the cutoff frequency of the low-pass filter that will smooth the curve, and second, the loading limit. It represents the loading limit at which the user is certain that the needle probe was in the interface. The inflection position is located before this loading limit. Here I have arbitrarily chosen a find contact function and plotted Fz versus position Z. With the interface detection with needle probe option from the Analysis drop-down menu, I can select automatic mode. As you can see, the software attempts to locate the two positions with the specified parameters, but it is not quite right, as these parameters need to be optimized for each sample. For instance, I will change the low-pass filter cutoff frequency and the loading limit values as shown. If you would like to manually adjust the cursors, you may do so by selecting the manual mode. It should be noted that the positions should be manually checked by the user as verification even when using the automatic mode. A user license is required in order to obtain the results of the interface detection with needle probe.